Here I am going to be talking about some tools to infer or deduce the type from the initialization and from expression. In C++, DECL type is a tool which was introduced in the standard in 2011. It allows to query or to infer type of an expression without actually evaluating it. The query type can be reused as a type of another variable or as a return type of a function, etc. It also picks a constantness and references from the type of an expression. Whereas auto is a tool for inferring type from the initializer, the value. It does not pick the constantness and references. In the following, I will explain these tools from the perspective of 4 different purposes. So let us go one by one. The first purpose is to define a variable inferring type from its initializer. This is useful when it is complicated to manually determine the type of the initializer expression. That means you are creating a variable and you are setting that variable to an expression, and it is very complicated to determine the type of that expression. In that case, this tool is very useful. Let us learn about this through coding. So first let me have a variable int x equals to 5 just to demonstrate the syntax. I want to create a new variable y, and I want to set this to x, and I want the compiler to determine type of y based on the type of the data it is set to. Then I can put this keyword called auto to ask the compiler to find the type of y, to set the type of y based on, same as the type of this expression that it is set to. Then if I want to see what is the type of y, so in this case we should see the type of y is integer. So we have compilation and linking, and execution. So I is displayed, that means it is integer type. Now if I want to do something else, for example here I want to cast this into double type. In that case the type of y should be double. So you can see D, which indicates that the type of that newly created variable is double. Next, suppose I have a reference to x and let me also have r value reference to a temporary expression. It could be 10, value 10, or it could be some value, for example x plus plus, or it could be plus x. So let me keep it 10. Now I want to create other variables by setting by initializing those variables to this expression, this variable as this reference as expression, and another R value reference as expression. Y1 equals to IR and Y2 equals to IR. And now in this case, this auto keyword doesn't capture the reference. It only will capture this type int. So in this case, it will be simply integer type. So we should see integer in the output. I should have used this expression. Let me go back and check it. This should be IRR. So both are integer. Now if I have a constant integer type ci equals to 20, and if I use auto, it will not even capture constantness. It doesn't capture a reference, it doesn't capture constantness. If I want to create a, let's say, reference, then I would do something like this. Auto y, let me call this y3 equals to x. And if I want to make this y3 as a reference, then I should put this the symbol here. And if I want to okay, let me go back and try to understand this better. In this case, here, if you want to see whether this is actually reference or not, what you can do is you can try to display the address of IR. We can display the address of y1, and followed by address of IR, and followed by address of x. And also we can do address of y2 and address of IRR. So let us see the output by these two lines. So we have first the address of this was the reference. Let me just copy this two lines in the code and try to understand from there. So these are the outputs here. So the address of IR and X is same because IR is the reference to X, and IRR is R value reference to this data. And if you see y1, the address of y1 is not same as the address of x, therefore definitely y1 is not a reference, and also y2 is not the reference to this data. That means auto does not capture the reference from the expression to which it is actually initialized. Similarly, I have this constant and I use equals to ci in this case it will not even capture the constantness. Let me just have this here. So I will be able to modify y3 equals to this is going to be a different variable which is actually set to the data 20. So this will not be a constant variable. You can copy another data to it. You can make changes to the data stored like this, and after that you can y3 so go back to the terminal. So y3 is 30, so it is allowing me to make change. So if I want to create a reference, then I would be doing something like this. If I want to create a y1 as a reference, then I need to put this character here, and then it will actually make this y2 as a reference. So in this case we will see the address of y2 and address of IRR to be the same. Similarly, if you want to make it constant, then you need to put the keyword constant here. So this expression will actually compiler will actually complain error in this line 29 because this is now constant. So this attempt to modify should be an error. So it is already complaining. So it is now it is that variable, that new variable created y3 is constant. Let me compile one more time. So you can see now the address is same, right? So now the variable is a reference, and in the second case also it is a reference. So this proves that auto keyword does not capture the reference. However, this keyword is pretty much useful in many cases when the expression that is used is very complicated. The expression that is put on the right hand side is kind of, this is a little bit complicated than x, but typically the expression you would use in the programming might be pretty complicated. For example, if I have a lambda expression something like this, expression which receives an array and computes let's say summation of all the elements equals to 0 for int I equals to 0, I less than size I plus plus, and sum plus equals to data I, and then return sum. This is a lambda expression which actually returns the summation of the elements of an array. And if you want to give name to this expression, then I would do something like this, my lambda equals to, but what is the type, because this is a variable, right? So what is the type of this variable? It's very difficult to figure out. So it is easy, very convenient to let compiler infer the type by using keyword auto in this case. So there are many instances in which this auto keyword is going to be very useful. The second purpose here is to declare a variable to be of same type as another variable or expression. This is useful when you cannot determine or it is complicated to determine the type of the expression manually. Let us try to understand this through coding. So in this case, let me start with very simple, very basics. If I have a variable x equals to let's say 5, and I want to create a new variable called new x, but I want to I don't have initializer. If I had initializer, I would be using I could use auto, but I don't have initializer, and I want the type of this variable to be the same as type of this variable x or expression x. So in that case, I could use this operator or function and put that expression inside. So it will determine the type of this variable to be integer, even if it is initialized to, it doesn't matter what you initialize to, 3.6. If it is initialized to double type, still this variable will be integer, and it will truncate this this part, and it will keep only 3, like you can see here. And also you can see the type of this variable, type, let us see this in output. So you can see the value is 3, 6.6 has been truncated, and the type is integer. And the next example, for example, if I have if I, instead of putting this only x, if I have a little bit I mean complicated expression like plus 1.0, in this case this new x, let me I will not be allowed to have this same name variable twice, so let me make this different name, and let me display what happens. This is going to be new x2 and new x2. This is just a type. Okay, so in this case you can expect that this is integer and this is double, so the result of evaluation of this entire expression will be double, so this variable should get a double type. Right, so now you can see the decimal part is not truncated, and the type is double. Now one of the benefit of this DCL type compared to the auto, one benefit I already mentioned, it doesn't depend on what it is initialized to. You can just define a variable. Initializer is not necessary to create a variable. And another thing is that it actually another benefit of this DCL type is that it actually captures the constantness or references, which is not done by auto keyword. For example, if I have int reference xr equals to x, so xr is a reference to x, and if I create a new variable, let's say y, and making it using DCL type and using xr as an expression, if I do I mean use xr, then I can compile this, and when I compile, it will complain. The complaint is that y is declared as reference but not initialized. That means it is actually considering this type as a reference type, exactly the same as the type of this XR. So you need to initialize it to something, maybe XR or X. Let me initialize to X. Now if you see the address of the three expressions, one is Y, and one is XR, and X. In this case, I expect all these addresses is going to be same, because XR is reference to X and then Y is also reference to X. Now so you can see all three addresses same. This is the address of variable X, and also it actually also captures the constantness, like const let's say int let me call this IXC equals to 25, and I use XC and create Y, let me call this YC equals to 30. And if I try to modify YC equals to 40, that will be this will comparison will complain this, because YC is because SC is constant, so the type here is going to be called constant in integer. So this YC is a constant variable, so this should be an error. So it is already complaining assignment of a read only variable YC, that means it is a constant variable. And one more example, if I have a pointer pointing to X, then if I use decltype with this expression IPTR, it will actually be a pointer type. It is a pointer. So this type followed by name of the expression, let me call this OPTR, then I can use to use this pointer to point to X again, and I can display the data through this pointer. Right, so this should be a pointer pointing to this X, variable X, and then this should be getting data from that variable. So I should have commented that out. Let me go back to the code, and so I should have commented this statement out. So we have the value 5 accessed through the pointer. So this value was actually accessed through that pointer, OPTR. Now I will be talking a little bit complicated exercise here. So for example, let me create a class. So uh, I can have a class called, let's say, numbers, and then enter numbers size, and then let me hardcode the size, make it a fixed value, constant size equals to, let's say, 100, and I have a function called, I want to have a function to initialize this array with random values. So this function will do that job for int I equals to 0, I less than size I plus plus. Random integers equals to rand times 1.0, just to make it double, so that division is not integer division. X times 100. This is a function to initialize, and we also want to have let me have a variable called, let's say, average, and I also want to have a function to which will actually compute average of these numbers and write in this variable. And just when using this function, we have to pay caution that this should be called only after the array is initialized. So just I'm trying to keep this simple. I don't want to complicate, make the code complicated. Double equals to 0 for int I equals to 0, I less than size I plus plus, plus equals to, this is just a summation of the numbers, and after that you want to divide by size to compute average. And if I want to write this value to this variable, this is a constant, right? So it should have been actually initialized. This constant should be actually initialized in the constructor. You cannot change once this object is created, so it has to be initialized in the constructor in this way. If it is to be initialized in default constructor, then you should put that in this initializer list. Right. So and if you want to change this function is going to be called afterwards. For example, let me call this here, and then after that initialize function, and I actually want to compute average after it is initialized. Here call average, and then once initialized, it will be automatically call this function. And now when this function is called, at that point this is already set to constant, so this is non-modifiable. So you can use constant casting to just remove the constantness for for temporary purpose, right? So this I want to actually since we have this this variable will actually shadow this this variable, remember. So we want to use this operator to access this the instance variable. And if I want to cast using constant cast, I need to cast to the pointer type. So I should consider address of this. This thing has to be cast to let me cast this to non-constant double type. We have double, so non-constant double. Use a constant cast and then to, let's say, double pointer, because this is address, so you should cast this to the pointer. And if you want to use access the memory, you need to dereference it. So, and after that you can set the computed average value to it, right? So now initialize, after this function is invoked in the initialize function, it will compute the average and then set that average value into this variable. This is not a good programming style. You have to avoid I mean this you have to try to make this name and this local variable different if possible, but just I'm trying to demonstrate something here, a possibility. Sometimes you may be constrained to use the same name, so in that case this actually gives a possibility of having that. Now we have here and then after that I actually want to have a function to display it. It will only display the numbers once it is initialized in the form of an array for int I equals to 0, I less than size, and I plus plus, and just display the numbers separated by a space. And closing bracket followed by new line. So this is the display function, and I want to call display. Once it is initialized, I want to display it. So this is the class, and if I want to get this average value, right? If I want to get average value, this this value from outside, what we can do is sometimes this variable maybe this type, considering that this type may be changing, and you want to give a consistent function to the user, you can have a return type actually determined from that, the type of this average. If I want to return this average, then I want to determine the type through this average. So I can use a decltype in this case and avg, and then the function name is going to be get average, and here you can return, and the syntax is, if you return like this, it's going to be returned by value. If you put inside parenthesis, it's going to be returned by reference. So, and before returning, you can decide to display this average from inside the function. I think when you return average, it is not useful to have this, so maybe we want to, yeah, since we are returning the reference, then I think we would want to see the address, so that we can I mean, when just to check that whether this decltype actually captures the reference or not, right? So this should return by reference, and then this decltype should capture reference, and whatever is the variable it is assigned to, that should act as a reference to avg, and the address should be the same as the address that is displayed in this place. Okay, That is I mean it is actually, this will solve that purpose. So let us use that this class numbers here, object name nm, and I could call nm dot that function we had here, this function get average. This is simply return average, and then just see what is the type of the thing that is returned. And also I want to see the address of the thing that is returned. So let me just display address here. So let me compile this and see the output. Let me try it a little bit differently. So put in the parenthesis entire thing. So I'm going to be doing a little bit differently here. What I do is, let me use a decltype, and then have a variable, let's say call this retv, and equals to, so I will be actually printing the address of this retv. So let me execute. So we can see the address that was displayed outside. I think this was, let me copy this, take it to the code and try to explain it. So we have so this was displayed by this. Looks like this is not same. Let me go back to the code and try to see what is the problem. I get average, this is, and here, I think I've, so because the type here is determined here, return type is determined by this function, but this is simply the expression. So if you want to actually return the reference, maybe you can put this here, this inside parenthesis. In that case you don't even need to return like this, so it will be actually returned as a reference. And then after that I mean this type, whatever is returned, you can also if you don't have put this parenthesis, it will be returned by value. So you actually return here, yeah, and this will be reference type at this point, and then this will be actually acting as a reference to a variable, which is the this variable. This is not a good programming style. This actually breaches the data privacy, but I mean, this actually solves the purpose of demonstrating what how you can use this decltype to capture the reference in the function return. So at this point we have this, and then it is returned. So let us try with this, try to compile and see the output. So we can see from the inside the function, I mean inside the function invocation, this is the address of that average variable, and this was the address of that variable that was displayed through the reference. It is the same address. So let me go back to the code again. So this is now this variable is actually serving as a reference to the variable that is inside the class. So this was another example, a little bit complicated, but and finally I want to actually discuss one example with the use of for loop, range based for loop. If I have array of let's say size t type with 5 elements, 1 2 3 4 5, and if I want to use a range based for loop, ideally I would use size t reference and or size t and element my array, and then I'll display these elements like this, right? First let me make sure that this actually displays the elements. So it is displaying the element here. Back to the code, and you can also use decltype to actually determine the type here, right? So for example, decltype, and then the type of this identifier should be the type of this elements of this array. So you can just include one first element 0, so it will actually find out that type and then do the iteration. And finally, final note here, this will be this decltype will appear more useful in more complicated expressions. So yeah, I think that is the final note I have on this topic. Next purpose here is to retain the constantness and reference of an expression in using its type to define another variable. So this purpose will be more clear when I actually start discussing the code. I will be using the same code that I used to discuss in the previous case. So we were having one problem here in this type. To return as a reference, actually we had to actually specify is at a reference type. So if I actually want to, upon returning this reference expression, if I want that reference to be returned, then I can use this syntax. It is a decltype with auto inside, and this is the syntax combination of decltype and auto keyword. It will actually uh, return. It will actually capture the referenceness of this expression. Right. So let me use it here. So I can use the same code, and I want to make sure that this is actually referenced at this time. So let me go to the compilation and linking. So it is only available with 14 standard. So I have been using 11 standard. So this was actually added to C++ standard in 14. So let me change the compiler to 14 standard and execute. So now you can see it is actually returned the reference. It is capturing the reference, right? So we didn't have to explicitly specify that reference in the return type. I mean the expression that is placed as a return type of that function, get average function. And also let us check whether, because this was returned as this is average was returned, and it was constant. So let us check whether it is returned as a whether the constantness is also captured in this case or not. So let me try to make change to equals to, let's say, 3.33 or plus equals to 1. If compiler complains on this statement, then it is actually also it has also captured constantness. So it is complaining. So it is saying that it is only read only. So it is a constant reference. That means this expression, this syntax is actually allowing us to capture not only the reference but also the constantness of this in this place here. Now in the same feature, same tool, not to mention that if you, for example, you can also try doing this with this constant and if maybe you can try to experiment this with let's say something like this. Do it y1 auto, and then y1 equals to, let's say, maybe we can make it we can create another constant reference, and maybe call this C. No, I think let me have a constant integer, call it cx equals to x. So, and constant integer reference cxr equals to x. So we have two variables. One is constant, another is constant reference. And if I want to use this syntax for this, y1 equals to let me use it, let's say cx y2 equals to cxr. So we can try to make change y1 plus equals to 2 and y2 plus equals to 3. So let me try to compile and try to see whether we can get error in that place. I think I should also comment that previous statement which was giving us error. Comment this out, and we want to only focus on this statements. So it is complaining. That means the constant is already captured there. And also if you want to see whether the reference is captured for the second because this is reference, so whether reference is captured to y2, we can display the address y2 and also display address of CXR, and also display the address of it is going to be it's going to be CX. Again I need to use 14 standard, and so I hope this is let me just copy this. Probably this is the address that output that is displayed by those statements. Copy this 2 lines into the code. And I think that this the second line was displayed by this we have this address of y2 and the CRX is same. That means that is captured, but maybe there is a problem with this selection. So CRX is X, so which I think we should have looked into the address of X. So this is actually I should have displayed this. This is the address of X. So the constant reference has been actually captured. Okay. The purpose here is to determine return type of a function based on the type of parameters. It is particularly useful in determining return type of template functions where actual values for which the function will be used is not certain when writing the function definition. So let us do it in coding. So I'm going to be cleaning this code up, remove everything, because the example I'm going to discuss is totally different here. So if I have a template function which receives for example let me create a the code that uses that function. So I want to have a template function which receives two arguments. Sum is the name of the function and it receives two arguments, and the type of argument can be either integer and integer, or it could be sum 3.3 and 4.5, double and double both, and call sum and integer and double, or double and integer type. So in this case, I want a return type to be integer, both integer type. In this case, obviously double type. In this case also integer is added to double, so result will be double. So it should be double type, and in this case it should be also double type. So in one case it's going to be integer type, but in the beginning when you define a template function for this, like this, t, and if you define it to be like this, then you are not allowed to be flexible to set a different type for two arguments, two parameters. So if function has to consider different type for these two parameters, then you have to use two type parameters, call it u, and then first is t, second is u. And if this function is to do the summation of these two parameters, then it is not certain what is going to be type of this expression that is going to be written. In the first case it should be integer, but in other cases it is double type. So if you use t, then in this case it is going to be integer, in this case double, and then in this case integer. We want double type. In this case it is double, right? So if you use u as a return type, then in that case also we are going to have the same problem. So compiler cannot determine the type here. So in this case it is good practice to let compiler to infer type using keyboard auto, and then once a compiler scans the type of a and b, then you can infer that you can have that expression as a something called trailing return type here, and you can put that expression a plus b. So at this point compiler can evaluate the type, because compiler had already scanned a, b, and compiler knows type of a and b. So this is how you can ask compiler to infer the type, and this is one of the uses of this decltype tool. Now it is the end of this exercise. Thank you for watching this recording.